We were just introducing our two speakers, or actually one principal speaker, Ken Levinson. And then at the end of this, we're going to be introducing David Can, who's going to help with sort of closing pieces of this evening presentation. This is our 13th webinar of this 2020 to 2023 season. Ken is really an interesting person. Right now, he's executive director of the Passive House Network. I was reading that he has a 20-year history of practicing architecture in New York City, and he became a certified passive house designer when passive houses became his passion. And he even created a business supply of high performance housing components. Also, he worked with the UN to create some framework guidance for energy efficiency standards. And he is a climate activist. In fact, willing to be dragged away from a street riot, I think, to get his point across. So I think he's the ultimate activist that I've met. Now, I'm sure that this activism is driving his keen interest in low greenhouse gas from buildings. In New Jersey, I mean, he's from New York City, but in New Jersey, 26% of our total greenhouse gas is from buildings. And we have our New Jersey 50 by 30 Building Electrification Team here to help reduce those building greenhouse gas emissions. And tonight, Ken is going to describe the 5 principles of passive houses to lower energy use in renovations, upgrades, and new building construction. We should say a word about chat. You're encouraged to write all questions you want into chat, and Pat Miller, my wife, will be our chat monitor tonight. Pat, is there anything else you'd like to say?
No, we'll have all the questions at the end, unless there's something that you absolutely have to ask in the middle. Then you're allowed to. But we'd like to wait. Just put your question into the chat or comment whenever you think of it, and then we'll go through them at the end.
Thank you. So Ken, the floor is yours.
Great. Thank you, Steve and Pat. It's great to be here with you. And yes, please put your questions in the chat. I don't need to be anywhere, so I'm happy to hang out and answer the questions. And I know David is going to be doing a questionnaire and talking a bit afterwards, but happy to hang out, as it were, and discuss. It is a passion of mine, as was noted. Definitely came out of being as an architect, being frustrated about the state of buildings, and seeing Passive House kind of as an aha moment that spoke to the magnitude of the problem that we're facing with the climate emergency. Passive House speaks to a similar magnitude of action. So thank you again for joining us, for having me with you. I hope this talk has you thinking differently about buildings and ready to act in new ways. We will talk a little bit about the principles, a bunch of different introductory material, and really why Passive House. The Passive House Network, just to briefly say, is a national nonprofit organization. We are based out of New York, but we are nationwide. We have 7 regional chapters currently, including New Jersey Passive House. And we're very happy to have David join us for the January chapter meeting. And all are welcome to come and share ideas, get information, make connections. It's really about the peer-to-peer knowledge sharing. We like to say that people who want green buildings often don't have a clearly defined realistic target or set of targets of what sustainability really can be with buildings. So we provide education and community to professionals, consumers across the building industry so that they can make the best design and construction decisions. So we're affiliated with the Passive House Institute and the International Passive House Association based in Darmstadt, Germany. It's really a global network of knowledge sharing and really leveraging that global knowledge and bringing it to regional contexts and local conditions. So we really are about connecting people, and we hope you'll join us. So buildings is the focus, and whether you're an architect or an owner or an occupant, they are incredibly important. And the fact is, they're basically have been failing us, right? We spend 90% of our time indoors, and you'd think they would do a better job by us, but they account for over 40% of global carbon emissions. It was interesting to hear the statistic of 25% for New Jersey. In New York City, at the other end of the spectrum, it's like 75% of carbon emissions. So a huge proportion, any way you slice it. Utility costs for maintaining these buildings are too high, and energy insecurity is only growing. Too often the buildings are unhealthy, and they're making us sicker and poorer. And this is a real mechanism in driving greater social inequality. And there's huge issues about safety and resilience, sheltering in place when the power goes out in extreme weather conditions that are only growing. So we know we need to change things. We need to make our buildings sustainable. But what does that mean exactly? It's one of those fuzzy words. And we realized pretty quickly that everybody has their own definition, their own set of priorities. I like to think of it as a green Rorschach ink blot test. And there's a multitude of areas, right, to consider. From reducing carbon emissions to affordability and social justice issues. Historic preservation can be a key component. And of course, electrification, issues around net zero, health and pleasure and comfort, of course. This sort of array of things to tackle can be exhilarating, but it can also be paralyzing, because you're kind of like, what do I do now? What are the steps? And we see Passive House as really being able to help that, because it supports fundamental building principles and fundamental building performance. It really, Passive House assures that you're tackling whatever your priorities might be from a position of strength, that Passive House can serve as the platform for your goals. And despite its name, Passive House, it is utilized in all types of buildings. So we're happy to very much talk about single family homes and housing of many different types, but we want to make it really clear that it can be for all types of buildings. You see here, university building, the factory, high-rise office building going up in Boston, libraries, schools are very popular. To become passive houses for both new builds and retrofits and renovations. So Passive House is applicable. We don't want to silo it. The trick is to let our imagination run wild with the possibilities. So Passive House we're setting up, as this sort of powerful thing, and it partly comes from the fundamental nature of its simplicity. It's just building science, right? I mean, there's actually nothing really revolutionary here. It's the rigor of the simplicity of it. I won't compare it to the importance of E equals MC squared in any way, but to say that it's a fundamental equation, E equals MC squared, and Passive House tries to boil down performance in not a dissimilar way. To be simple and clear the static from our view so that we really see what the possibilities are. So this is a little wordy, but we'll dive into it. The Passive House concept and the simplicity starts with the occupant's comfort and health. It is an energy efficiency standard, but comfort and health are not side benefits of Passive House, but core to its meaning. Efficiency is deployed in a way that makes us more comfortable and healthy. And so this is quite a shift from how we would typically think about energy efficiency, right? Historically, I know growing up It was about discomfort and deprivation. You know, turn down the thermostat, put on a sweater, suffer a little bit, and you know you're being efficient. Passive house turns this on its head. So the definition of passive house and its functional definition, sort of Platonic idealized definition of it that it springs from. A passive house is a building for which thermal comfort, ISO 7730, can be achieved solely by post-heating or post-cooling of the fresh air mass, which is required to achieve sufficient indoor air quality conditions without the need for additional recirculation of air, period. It's wordy, but that's it. And what it's describing is maintaining comfort and health with 100% fresh air, with very low, that fresh air that's coming in is relatively low volume, and it has a very low capacity for heating and cooling. So you need a very efficient building enclosure to be able to achieve this. And so consequently, and we'll go into all of this in a second, the health and comfort and efficiency are all working in the same direction. They're not working against each other. They're actually supporting each other. It's a flip kind of in logic that we've experienced with our computer industry, right? We expect our computers to be ever more powerful while using much less energy. And so too, passive house decouples performance and power. Passive house is the world's most rigorous energy efficiency building standard. It really implicates business as usual practices and forces us to make high quality architectural enclosures first. It empowers architectural solutions that can support a wide array of sustainability goals. And really, it is to a point of efficiency where in your home on a very cold winter day, you could heat sufficiently with some candles. That's where the heat load and heat demand is driven down to. Architects can sometimes fear this as a set of restraints that are just too much, but I think we'll see it actually empowers architecture again as a solution, as a driver of all of these sustainability goals. So it's about the energy balance. This diagram shows homes, but it could be any type of building. Heat losses are shown below the middle line of equilibrium and heat gains above the line. We could also flip this to be about cooling in a hot climate. So in the old, very leaky building and the modern, moderately leaky building, shall we say, these homes have large active heating systems, right? They're required to have a large heating system to make up the difference, to bring the building into balance, as the losses below the line must be offset by the gains above the line. And we see in the passive house building requires a tiny fraction of the energy to be brought into balance. And this dramatic reduction in heating and cooling demand demonstrates the power of the optimized passive architectural structures. And we see that the building has done most of the work to bring the energy flows into balance, and it is just topped off with that active heating and cooling systems. And so this starts to flip our expectations about what's possible. So a key aspect of the simplicity and delivering this kind of results, dramatic results, is that passive house is not grading performance on a curve. It's not relative to how bad or good the building was before. It is based on rigorous fixed targets for key drivers of performance, like the air tightness, the heating demand, cooling, dehumidification requirements, and energy use intensity. And is this sticking to hard numbers doesn't let you wiggle out of the performance goals. And so there are specific certification levels to passive house, each with a baseline of performance. And then we can add, so that's Passive House Classic, and then we have Plus and Premium, where we're adding in integrated renewables. we're not necessarily going for net zero per se, but we're going for higher performance and higher integration. You could be going for net zero, but it's not necessary in terms of the certification. It also has a set of certifications for retrofits, and similarly has a baseline. It's called ENERFIT, the retrofit standard. Has a couple of different approaches to it, because there are certain things unique to renovations with existing buildings that you can't undo, like the foundation conditions and historic requirements, perhaps, or other things. So we have those specifically. So that simplicity and rigor in the approach brings predictability, and predictability is super important. We're investing our time, we're investing our resources in buildings. In whatever we're doing, we like predictability, right? We want predictable outcomes, and Passive House does that. Passive House actually lowers the risk profile and protects us from the variabilities in the future. And I think we'll see that a little bit coming up here. Passive House is the most predictable building standard. And that's really in part because it's basic building science, of course, but it's rigorous and is based on scientific research. This is the first passive house, modern passive house, built in Darmstadt, Germany in 1990. It was built as a research project, a physics experiment, by an international team led by Wolfgang Feist, the founder of the Institute. It was and still is today composed of 4 attached row houses, complete with custom building components developed for the experiment itself, because things like the windows that they needed, the ventilation system, they did not exist at the level that they needed to be at that time in the market. So they made custom components. And the research that was conducted there solidified the underlying principles and strategies that would become the Passive House standard. The story goes that Amory Lovins from the Rocky Mountain Institute visited the building and provided the insight that these new developments could be standardized and scaled to affect the building industry as a whole. So from that time on, the Passive House Institute has continually conducted research going forward, developing new tools, working with new building types, the new climates, going global, if you will, working with government partners and industry partners, to make Passive House performance predictable. So here we go into the principles, the 5 fundamental principles, which, it's more complicated than this, but it does boil down to this as the foundation of Passive House and its predictability. The first 4 principles are, as you might guess, focused on the enclosure of the building, getting control of that interior environment, with the 5th being mechanical ventilation. So we've got continuous insulation, air tightness, thermal bridge free construction, high performance windows and doors with solar protection, and high efficiency heat recovery ventilation. I'll briefly review them here in pretty simplified terms, but this is beyond information overload. So I think it's okay here in this context. So principle number 1 is continuous insulation, right? The building envelope is what separates the interior of the building from the outdoors, and continuous insulation helps maintain steady indoor temperatures with little heating or cooling. Think of it like a thermos, not the sexiest example perhaps, but a very utilitarian one that gets the point across. The insulation thickness is climate specific, right? If you're in the Arctic, you're going to have a more higher performance sleeping bag than if you're in the South. So it's climate specific and robust. I like to think of it as our typical building stock today. I would compare it to my teenagers who will go out in the freezing cold with just a hoodie on, and be, oh no, I'm fine, I'm fine, I'm fine, when it's just, miserable. The passive house is, a good parka, good hat, scarf, gloves. You can be comfortable in the cold if you're dressed for it, and passive houses are dressed for it. Principle number 2 is airtight enclosure. Airtight enclosure keeps the cold air out in the winter and warm and humid air out in the summer, while protecting the occupants from pollutants like smog, smoke, and allergens, and preventing drafts that cause discomfort and energy loss. So huge drivers of performance, health, comfort here with airtightness. And I'm sure there'll be questions around airtightness, and happy to circle back. I'll talk a little bit about it more in a few different ways here. A key aspect of airtightness that often people don't appreciate is that it's really optimizing the performance of the building's insulation, of the insulating value. Think of a Gore-Tex windbreaker over a fleece sweater on a cold, windy day, right? That windbreaker is going to make all the difference in terms of your thermal comfort. You could have a similar building, well insulated, one leaky, and one with good air tightness, and have 5 times the difference in energy demand and heating demand for that, just based on air tightness alone. Principle number 3, thermal bridge-free construction. So typical buildings have break in the insulation at construction joints called thermal bridges. So like where balconies come out of buildings typically, or window frames are connecting to the construction, or the window frames themselves. You see in the metal ones in particular, evidence of that. Intersections of walls and roofs and floors, structural elements like columns going through. Large amounts of heat can escape through these breaks. Typically, they are not considered, they're ignored, and we have to oversize all our mechanical systems because of this. In passive house, we really crank down on them because they can cause drafts, that can cause condensation, related moisture damages, as well as increasing the heating and cooling demand required. In a passive house, we ensure that the continuous insulation is unbroken, technically called thermal bridge-free construction, virtually eliminating these issues. So the 4th principle, the final one on the enclosure, is the high-performance windows and doors with solar protection. Windows and doors typically are huge holes in the enclosure, right? They undermine the performance of the building. So in a passive house, they are key elements in keeping the building airtight and the temperatures comfortable. Passive house windows and doors are often triple glazed and can be optimized to benefit from solar gains in the winter while minimizing heat gains in the summer. Passive house also uses solar shading as needed to minimize air conditioning in the summer. It's really important. These aren't passive solar houses in the traditional sense that we would think of coming out of the 70s, which were often very much overglazed and had huge comfort issues and energy issues for that matter. This is much more dialed in and carefully calculated. And really, we want to spend as much time preventing overheating because we want to minimize the energy use year-round. And what it does is it allows us to use all our space comfortably. You can sit by the window in the middle of winter, and not a small window, big windows, and be comfortable and enjoy all your space. So it may take a few inches of insulation away, but it gives back a lot more space. So with the enclosure in hand, with those 4 first principles, we need fresh air ventilation, right? And we want to bring in that air. It's 100% fresh air, 24/7. And we want to have good, efficient heat recovery. We don't want to throw that heat out. So I guess I should note first off that you can open the windows in a passive house. Natural ventilation is a core strategy of passive house. And when you can use natural ventilation, it is totally encouraged to do it. The problem is we can't depend on natural ventilation. A leaky enclosure isn't good because we don't have control over it. You have no idea what's going on. But if you want to open windows and doors and let the breeze go through the house up and down, side to side, on at appropriate times overnight for overnight cooling, for example, it's all great. But the problem is it's often not helpful, right? What if we have outdoor pollution? You're by a busy street, there's a forest fire, there's industry, there's any number of outdoor pollutants, allergens from the outside. You may not want that air flowing through. Noise is another issue that that we may want to keep the building tight and can't open it necessarily, or just because it's too cold or too hot outside. We don't want to bring in the fresh air in a way that's going to cause us to crank up the heat. With buildings, they all have mechanical ventilation, right? Where they typically have a bath fan and a kitchen fan. They're operating intermittently. We're relying on a leaky enclosure. We really have no idea how well any given room at any given time is ventilated. In a passive house, it's just much more robust. We're providing 100% filtered, clean, fresh air 24/7 to every space that's being occupied. Bedrooms, living rooms, classrooms, offices, assembly spaces, as needed to maintain that healthy, hygienic indoor air. Passive house ventilation ensures the clean and healthy indoor air all year round, not just when it's nice out. So we take these 5 principles and we ensure that the heating and cooling loads can be reduced up to 90% to allow for flexible design yeah, so the 5 principles we're putting through, I should say, through an energy model, the PHPP, the Passive House Planning Package. And this is a design tool, essentially. It's like an energy design tool with the architecture, architectural design, with the cost analysis, with all the different aspects, the specifications, and you are designing the building in a way that allows us to reduce those heating and cooling loads up to 90%. Because you're calculating along the way, it allows for flexible design while giving these results. We often see the heating and cooling. When I was practicing as an architecture, when I was practicing architecture as an architect, I should say, one notable example, a house I was working on in Brooklyn Heights, all the neighbors had 12 to 15 tons of air conditioning on their roofs, and the Historic Preservation Commission couldn't do anything about them because they were mechanical equipment. And we did a calculation for a passive house retrofit of the similar home, and compared to the 12 to 15 tons, and these are big townhouses, right, in Brooklyn Heights, we needed 1.5 tons of air conditioning, and which is a dramatic reduction. We ended up installing 3 tons because it just seemed too crazy. You know, you do want some buffer, but what we have is a buffer of 1.5 tons of air conditioning rather than a buffer of 5 tons of air conditioning. And so that's part of that optimization. So it's this basic building science, just rigorously applied, that drives the predictability of it. Now, it's also, you know, we have choices. There are different ways of doing things. And so just to note about it in the relative predictability. So in code-built buildings, you could get a really efficient code-built building, or you might not. And oftentimes it's all over the place. It's pretty unpredictable. And as a consequence, the mechanical systems are typically oversized for the worst case scenario. Even LEED and other green standards that have a lot of positive attributes to them in terms of the energy performance, the underlying energy performance, they can be all over the place. And too often they are also being oversized, the systems, and not dialing in the performance and all the benefits of that. Passive house is going to still have variation. You have different occupants, right? People like things at different temperatures. People use their buildings in different ways. The occupancy is going to change over the years. There will be some variation, but it's typically going to be in a quite tight band that allows us to downsize these systems adequately. Now, there's typically a question on cost. And of course, you know, we're talking about construction, and construction costs, you know, gives everybody a headache, especially in this day of the recent inflation and everything going on. So we have a marketplace that's tough to begin with. And what we too often find is that with passive house, if there's an issue one way or another, everybody's quick to pin it on passive house. If we dig into it a little bit, we realize that maybe these are just fundamental issues in the market and not necessarily specific to passive house. One example of the costs kind of possibilities is this graph on the left. And it demonstrates a lack of direct correlation between passive houses, which are the blue dots, and the non-passive houses, which are the black dots, and cost, right? In these examples, the passive house is integrated goal, is part of the affordable housing strategy. And on average, incredibly, perhaps to many, and is that they're less expensive than the conventional. And so we're not going to put out the expectation that passive house would be less expensive. This is higher quality construction. And, you know, typically you're going to pay for that. You should expect it to cost a little bit more, but just a little bit more. The fact of the matter is there are many issues driving the cost of construction. And if you are optimizing from the beginning, you should be able to keep that additional cost between, you know, 3 and 5%. If you're going more than 5% over, then typically the costs, the sort of optimization and the decisions along the way have not been really optimized. And so while we push for that, you know, we want to be realistic. While we push for parity, and we will get there as the market comes up, particularly, and people are more attuned to it. The best thing that we can do to stay on budget is to have passive house from the beginning of the project, whether it's a retrofit or a new build, from day one, rather than trying to shoehorn it in to a process later down the line. You want to work with the certifiers. You want to work with some trained professionals. You don't want to dig yourself into a hole that you need to dig yourself out of later. It's really critical to make those optimization choices along the way holistically. And if you do that and maintain passive house as a strict target, you'll get there. So the simplicity and the predictability allow it to be supportive of a wide range of goals. Again, speaking to the health and well-being of the occupant, hygienic indoor air quality, 100% fresh air and exhaust with no recirculation, no mold, no associated illnesses with that, reduced asthma and allergens. This picture, again, can't get enough of. We want to be comfortable, right? Steady temperatures, no drafts, no cold feet, peace and quiet. It does give people peace of mind. And in terms of resilience, security, and equity, high quality, comfortable, and healthy homes that cost dramatically less to operate and allow people to shelter in place. It protects people from future energy shocks. Affordable housing is a huge driver of passive house. It was in Europe in social housing from the beginning, and we're seeing it in the United States, where it's being incentivized, and really passive house is high quality construction that is deliverable for everybody, which is critical. policymakers in looking to go to zero carbon, right? Any policymakers seriously, and most have done their carbon budget. And we're talking about the percentage of carbon that buildings make up. So if you're looking at a big chunk of carbon that buildings are need to take care of, Passive House is a good tool. And we see more and more policymakers turning towards it for support. Electrification and renewables. So as we electrify and as we push towards renewables, really the critical thing is to reduce demand first. We want to go net zero. We want to be 100% electric and 100% renewable. But the best, what do they say? The best electron or the best measure of energy is that energy that we're not using, the most efficient. So if we can drive down that initial demand, it makes things much more flexible for netting out zero, much more economical, ultimately, for the community, for the grid, for society. Then we have embodied carbon, which is a whole other topic, which is super important. How Passive House really supports this is making it darn obvious that we need to deal with embodied carbon. Typically, embodied carbon, which are the gold bars there, it's the energy and emissions based on building the building initially and then maintenance and repair going forward. Typically, the operational emissions overtake it pretty quickly. But if you've reduced those operational emissions significantly with Passive House, then the embodied carbon becomes the 300-pound gorilla and needs to be dealt with. So we certainly encourage driving towards embodied carbon, and a lot of folks in Passive House are moving towards that now that they've got the operational under control. The UN Sustainable Development Goals are a wide range of things, and Passive House speaks to many of them. Just a couple of more quick notes here and we'll be done. So simple, predictable, and supportive. It really does allow us to think and work differently and change our expectations for what buildings could and should do, what they can deliver. So we like in these presentations to note that typically the people that are at these presentations, which no doubt you all too, are the change makers. You're active in your community and you care about the climate and sustainability. And so really the point of this is to get you all thinking, to think about Passive House and hopefully take action and be, actively in considering it and thinking about it for you personally, but also in your work and in your wider community. If you're doing renovations to an existing building or planning to build new, we ask that you consider building to Passive House. If your community is adopting sustainability goals for public buildings and private developments, consider adopting Passive House requirements. This development's in Newton, Mass, and this developer, it's a massive project in Newton, the biggest in, maybe in forever there. And the local Green Newton sustainability activists essentially forced the developer to commit to doing Passive House buildings to get through the zoning approvals. And so you have huge leverage for all kinds of projects. And we're seeing Passive House being used more and more. Now, there were other sustainability goals too, right? There's the Rorschach test and a laundry list, but getting this Passive House baked in is really a game changer and one they pushed hard for. If you're hiring building professionals, consider require that they get certified Passive House training. So we like to say, let's build a world that's healthy, equitable, and sustainable. Passive House can transform the status quo, and we can do it together. So thank you for your time. And that is my presentation. So I'm happy to dive in. I've not looked at the chat because I need to stay focused, but I'm happy to discuss for a little while.
I'll just go through the questions that are in the chat right now, and if you have more, you can put them in whenever you think of them. So I think the first one that the first one that pertains to passive houses is the one from Steve about the relationship of passive house requirements to LEED requirements or net zero or other certifications.
Right.
And
So yeah, no, it's a great question. So essentially, passive house is really focused on, as we were talking about, the fundamental energy performance of the building, and then it's delivering this comfort and health benefits. LEED is covering a wide range of sustainability goals, right? Everything from urbanism to materials, transportation, many good things, all worthy things. But it does leave the energy equation kind of wanting, shall we say. And so you can have, there are many LEED buildings that don't even meet the energy code, okay? Today's energy code. So you could actually, in terms of energy and emissions, be in a worse place with the LEED building. Now, that doesn't need to be the case. And there are platinum LEED buildings that are that way. So it's not, a LEED building is not an indicator of actual energy performance. It could be, but it's not directly. For net zero as well is definitely, you know, we need to zero out all emissions, right, and energy use. The issue with net zero, in my case, and hopefully, and I think David, I don't know, have a discussion here a little bit too. Net zero is allowing you to use pretty much any amount of energy that you want, as long as you offset it with renewables. So you could have a very inefficient building and have a net zero building. And there's all kinds of examples around that. So we want to drive at efficiency first and really go as far as we can, and what's reasonable and optimal. And that's what we think passive house represents. So you can have a net zero passive house building. You can have a LEED certified passive house building that has those, shares those performance attributes, but they're not necessarily serving the same things in and of themselves.
okay, thanks. The next question is from Holly, and I'm going to expand on it a little bit. She asks about insulating a 25-year-old home, and I'll expand. You mentioned that the same principles apply to retrofitting homes, existing homes, and I just wondered if there's a short version of how one would go about that, because most of us have existing homes.
Yeah. So I would say what you want to do first is get an energy audit. And I don't know if what New Jersey clean energy programs there, they may have money for doing that and have somebody come and do an inspection and see what the low hanging fruit is.
Yeah, they do that.
Yeah, that is definitely step one. Like, just do the inventory of things. Now, if you're setting off to do a passive house retrofit, you'll take care of you'll take care of all the issues. But so it's not really the age of the building, although, you know, certain buildings built in certain decades may have certain similar characteristics. It's just whether how well it was done. So oftentimes the insulation isn't that good. It's not that continuous. There's certainly, the air tightness isn't that good. They're not. So most buildings, I would say, will definitely benefit from insulation and air tightness. And we see replacement of windows as a huge thing. And then it's really a matter of, in the EnerFit approach, you oftentimes, because people don't necessarily have the luxury of, you know, buying a building, retrofitting it, and then occupying it, right? You're going to be doing it step by step, piece by piece. And the big thing that passive house shifts there, typically when we see with retrofits, is you're going to replace the windows. and they say, well, the walls aren't that good and it's a leaky house. Why, you're not going to put that good a window in to replace. You'll get a better window, but not a great window, because it'll never pay for itself. It doesn't make sense. In a passive house step-by-step retrofit, we say, no, we're going to put in the best window that we can. And we're going to install it in the best way that we can. And then when we can do each part of the building going forward, we're going to do it to the best that we can. And then over a period of time, we're going to end up with a high performance passive house building. And there, there's some things around that. So probably insulating is great. The 25-year home. So what type of certain type of insulation? So do you have insulation in the walls right now? Do you know? Because you can blow in insulation, you need to inspect it and see what's there. A lot of the homes are getting wrapped, right? You take down the siding and you wrap the home in mineral wool often now, which is great. It's fireproof, which we like, and good insulator, good with water. And then put the siding up over the insulation and redo the windows. Or you can go on the inside. So a lot of folks may prefer to renovate the outside or need to renovate the outside because it needs some work generally, or they may be thinking about renovating the inside. So this may go different approaches. Sorry,
Okay,
it's not
great.
such a specific answer.
Well, it's a big question. I knew that.
and buildings are super complicated. It's never quite one size fits all.
Right. I think you already answered the question about opening the window, so I'll skip to the next one, which is in regular buildings, wires and pipes are in the walls, floors, and ceiling. Where do they go in a passive house?
Good question. Pretty much the same thing. You want to make sure that so the pipes and ducts and things like that, you want to try to keep them out of the exterior walls, right? So that you're really allowing for the insulation. A lot of times, if they do need to go in the exterior wall, we'll have a service cavity with the wall. So the insulation is maintained as continuous, and we have a good airtight air barrier that's continuous. And the wires and outlets will be just inboard of that. So you'll have some furring strips, and then you'll have your interior finish. So you have like a thin mechanical chase, like the depth of a outlet to run the wires and stuff, while maintaining the continuity of the enclosure.
Okay, thanks. The next question is, are there modular passive houses? And question, are they less expensive, cost of retrofits? Let me just say before you answer that, some people on here might remember that we had a year ago or more, friends of ours, Diane and John Burke, were building a prefab passive house that was factory built and put together on their house. They just finished it and are moving into it as we speak, and they've agreed to speak in our, I think it's the March webinar that we're having.
Oh, wonderful.
Which is the third Thursday in March. So it'll be Diane and John Burke will talk about their prefab house. And they're wonderful speakers and have lots and lots of interesting information. So I hope you'll all come to that. But now, Ken, you can answer.
That's great. That's great to know. That's very exciting. So the answer is very unsatisfying. It depends. Modular and more so today, panelization is, the high performance construction is moving towards that. And it is a way it should be more efficient, more cost effective, high quality, good quality control, and get a lot of benefits that way. It can still be you know, depending on who you talk to, they could build, you could probably still site build for the same amount or less. But you may not have the guarantees of quality or the assurance of what you're going to get. So that, you know, there are different things that people are looking for when they go for modular, or, and I'm not sure if everybody's familiar with panelized, but it's basically like a flat pack. So like if you bought your house from IKEA, it all comes on a trailer, and in one day a crane will put up all the floor sections, the wall sections, the roof, in a day or two, and then you finish out. Typically, you'll finish out the interior and button up the exterior. So that's panelized. Modular has a longer history, and their modular can be good, and it could be cost effective to the extent that a lot of modular buildings came out of more affordable housing. And if they're good about getting the more rigorous building standards, they can do it pretty affordably, you know, and cost less for sure. But there are a lot of players.
Okay, the next is a comment or an answer to a question from Steve. We were talking earlier about community solar, and there's a link that he gives. So if you look in the chat in the middle somewhere, Steve has put in a link to arcadia.com, which is where we signed up for our community solar.
Arcadia.com seems to have the biggest share of signing people up for the whole state of New Jersey. So if you go to arcadia.com and per the link, the first thing it'll ask you is your zip code, and then it'll tell you if you're eligible or not.
Well, also, Steve, you said you had spoken to people who work for Solar Landscape.
Yes.
And Ed Neblock, who is on this call, is in PSE&G territory, and he mentions that Solar Landscape is one company that serves PSE&G that provides community solar, and another one he mentions is Neighborhood Sun. So we at least know that PSE&G and JCP&L are starting to provide it. In JCP&L, it's not quite online yet. We're on a waiting list, but if you're interested in community solar, it's the next best thing. So let's get back to the passive houses. I just wanted to mention that. June asked, how do we find a certified installer for retrofitting, especially siding and insulation for an older home, and what are the appropriate certifications to look for?
Yeah, I'm not sure if I have a good answer for that either. So I mean, from a passive house perspective, we have certifications for builders, tradespeople, and architects, engineers, and it's really the competency and industry has really grown in a way through peer-to-peer knowledge sharing, either face-to-face or remotely, and sharing strategies and experiences, open houses, and all of that. For specific, you know, there are certifications for insulation installers, I believe. I have to admit, I'm not an expert down in certain aspects of that. But what I would say is, if, you know, it's like anything with construction, finding that somebody with quality, who does a good job, who takes pride in their work, who, you know, is doing work that doesn't cause 100 callbacks. These are, you know, you would think these would be reasonable requests. So it's really in the ecosystem, the local ecosystem, finding those recommendations through the community as to who's doing good work. If they're interested, because you're not going to get the thermal bridge free continuous insulation passive house sort of higher level performance unless those and it tends to be driven more from the architects or GCs that would be hiring the insulation contractor or the siding contractor, their interest in it and being able to plan it holistically. So it is, you know, there is a higher bar to entry in terms of engaging it, but it is possible very much. I think if you find insulators or carpenters who are excited about these issues and want to and see it, the biggest thing is seeing these folks, whether they're professionals or builders down to laborers, if they see it in their business plan, they see the future in it, then you can make good things happen. So.
Okay, thanks. I have one more comment, and then we're going to have the last question, which is from Robert Wilson. But Mike Winka points out that to get an energy audit, you need to go to in New Jersey, either your gas or electric utility for existing homes to get an energy audit. And new home construction is managed by the BPU Clean Energy Program, and Mike gives their a link to their website in the last comment that's in the chat. So if you're interested in an energy audit, either for a new or an existing home, there are those resources. Now, Robert Wilson is asking, what sort of counterflow exchanger do you use for ventilation air?
Yeah, good question. And it is counterflow. It's not crossflow, which is an important distinction. So counterflow, the outgoing air is going opposite the incoming air, and it passes by each other through this passive heat exchanger, right? So typically it's going to be some kind of membrane. It's a membrane. It could be a wheel in bigger commercial projects. The typical one in residential that's certified components is Zender America. They're out of Maine, but they distribute nationwide. And then when we go to commercial size, there's more options, Swagon, Ventacity, and so forth. But typically they're going to be ERVs as well, so they're recovering moisture along with the heat. But often they could just be straight heat exchangers. So I don't know if that covered it adequately, Robert, or if there was something more specific there.
I guess I was also wondering about the humidity exchange, because certainly in the summer,
right,
that would be a real problem.
Yeah. So that's exactly right. So that's the and that's why a lot of them are ERVs. They're exchanging the humidity as well, or they're not exchanging the humidity, I should say. They're keeping the humid air out and keeping the drier air in the summertime to minimize the need for dehumidification. We don't want our air conditioning systems to run to dehumidify, although they may need to a little bit, but oftentimes in New York, New Jersey, there will be ERVs.
All right, Ken, thank you so much. This was really a great presentation, so much wonderful information. But we do have one more thing we want to go to, and it's David Kahn. And did you want to say something?
I just wanted to, I put my email in the chat if anybody wants to follow up and stuff. Like Robert, I could give you the Zender America and other. I'm happy to give more specific information where I can. Thank you.
Great, thank you.
Thank you. So one more speaker, and that's David Kahn, who's one of our Building Electrification Team members and also an electrical engineer like me. David started with a desire to buy a highly efficient house in an over 55 development, and he wasn't able to get such a thing. So he then went to a broader range of developers and still found they would not do anything special for a tighter control energy efficient house. And so David has a story to share with us, and he's probably going to do this in the next 10 minutes. So David, I'm going to turn it over to you.
Hello, everyone. Thanks for the introduction, Steve. I was going to start out with a summary. Let me share my screen first. Just a recap of what Ken had said, maybe worded slightly differently. So we had discussed what net zero was, and again, it doesn't mean it's an energy efficient house. It just means that the amount of energy generated from like solar or wind is enough to offset the energy needs of the house. So you could have, as one of Ken's slides, the modern leaky house or the old leaky house. You can make those net zero just by putting in an acre of a solar farm, perhaps. But a passive house means that it's been highly engineered from the beginning. And the categories, recapping what Ken had said, there's the thermal control, which is high performance insulation, eliminating thermal bridges. I'm going to run through this quickly because it's pretty redundant, I guess. Air control, the air tightness so that you don't have leakiness. We discussed that also. And having balanced ventilation with these heat exchangers so that you're getting fresh air and not stale air, and with humidity control. Next is radiation control, and that's the solar insolation. So you're shading your house during the summer, and you're opening the blinds to let the sun in when the sun is low in the winter, as well as using double and triple panes windows. Moisture control is part of the ventilation system. So if you're bringing in outside air, which is great, especially in the winter, it's going to be very low humidity when it's heated up to room temperature, and vice versa. In the summer, you're going to get high humidity air in, so you need some sort of humidification and dehumidification. Then the last statements down here is also, as Ken had said, it's important that you do, if you're going to design a passive house, you do it from the start. And the idea is to reduce the renewables, well, the load of the house. So you don't need to you can reduce the amount of solar or wind or that kind of thing. You can save money there by just doing a better job with the house construction. Ken also mentioned this, that the cost difference is surprisingly little for getting a passive house. I remember Ken's graph. It might have been, what was it, $173 per square feet versus 175, which is well under 1%. But I got out of the FIAS Passive House Institute of US organization that it's can be as much as 3 to 5%. But in any case, it's very low. It's not like an exorbitant amount of extra cost, and you're getting a tremendous amount of reduction in your energy costs down the road from gas and electricity. So that's all I wanted to say here. In the footnote says that I got it from this website down here from Passive House Institute of US. The next thing I wanted to do is sort of what Steve had said about me and why I'm here and speaking tonight and my story, and then I'm going to get to a survey. So before I start my story, let me cut and paste the URL to a survey so that if you have time while I'm speaking, you may want to take a look at it and perhaps even start doing it. So let's see, go to the chat window and I'll paste it in the chat window. This is my own survey. You'll see that it's not a malicious site because it's office.com, which is part of Microsoft. So it's nothing unusual as far as the URL goes. Okay, so my story, my passion was to install solar panels. I did that almost 15 years ago. But now that I have a huge house and I want to downsize because I'm facing retirement and my kids are liberated, I want to get another house, and I really want it to be passive. I want to be, I could essentially be off grid. That would be great. EV car, all of my heating and AC needs and everything else without a bill to JCP&L or New Jersey Natural Gas. So I've been looking, how do I go about that? So I've been looking for vacant lots. I've been on Zillow for months and months and months looking at vacant lots. And there are so few. In Monmouth, I've been looking in Mercer and Middlesex County, next to nothing. And the couple that I've seen are either in undesirable properties, like they have drainage issues, or they're in neighborhoods that I'd rather not construct in. The other choice, if you're not going to go with a vacant lot, is to do a tear down. So that means buying an existing house and just tearing it down and building something from scratch. So Middlesex County is a bit more expensive than Mercer, and maybe Monmouth is in between. I'm not quite sure. But the tear downs at a minimum are in the 300K range. And in Middlesex, it's probably more towards 450, 500 to get the most basic house. It's in a decent neighborhood, quarter acre kind of lot. And so you're wasting out of pocket probably $200,000 or more before you even get started. And it really doesn't make too much economic sense because, I don't want to be paying for a new house and I'm downsizing more than I'm going to get from my existing house. So I haven't had success with that. So what happened next? A friend of mine invited me to a 55+ community built by Toll Brothers in Howell. And they're still building on that site. And so after touring her house, I went to the sales trailer and started speaking to them. And I said, hey, I see what your model homes are. Would it be an option to do a passive house, even if it's a prefabricated house that I could import? And the sales agents, well, they're not the ones that could really answer that. And they obviously said no. So then I went to Toll Brothers website, Lennar website, and Pulte, who's another large construction company. Went to the contact us pages and filled out some information about me. And so the answers that I've gotten back, at least from Lennar, was no interest, but again, it came from some other sales agent. So it's just so far not speaking to the right people. I'd need to speak to a corporate person that would be more empowered to make a decision such as this. So far I've been pretty much out of luck. So in discussion with Steve, we thought having a questionnaire and passing it on to everybody on this call and other Sierra Club members, maybe statewide and elsewhere, we could get strength in numbers in making our story to some of these large builders make more sense, even though it already should make sense, because as we said earlier, it doesn't make for a more expensive house. So why don't they just offer it? So with that, let me go to my survey. And I in the chat window, I gave you the URL for it, and that's exactly what I'm showing in my browser. Let me just quickly go through the questions, and I think there are 8 of them or so. And I see the number of responses has already gone up to 13. It was 8 about a half an hour ago. So the first question is the most important. How interested are you in purchasing a passive house in a new development? And so, I mean, any answer from extremely to not interested to not interested. But the last question that might interest some of you, you're not interested in purchasing a house, but it's a passion of yours. And I know Steve shares that interest, where if he could make it easy for everybody to move into a passive house, that's one of his passions, even though he's not necessarily going to buy one. So click that off in that case. Next, I ask questions, well, does it matter if it's a 55+ community or can it be any age? And again, either extremely interested to not interested. What's your time frame from under a year to more than 5 years? Or maybe you don't have an interest presently, but you don't know when the kids are going to move out. And maybe then you'll be more interested, so you can click that box that your interest might change. Then the next question is in which area, which county, Monmouth Shore, or just Monmouth in general, Middlesex, Ocean, Mercer. And if you're in any other interested in other parts of New Jersey or some other states, fill that in the other box. And by no means assume that this is geared towards central New Jersey. The question came up earlier about prefab houses. And actually, this is one of the best websites, unityhomes.com. And Pat had mentioned earlier, Diane Burke and husband had constructed a Unity House home, which I toured myself in Middletown. And it's quite impressive. So check out their website if you're interested. And they make prefab homes. They should be cheaper than a custom home that's passive, but I don't have any information to support that. But in Unity, the house that I was interested was probably going to be in the $450,000 range. They make some larger and more expensive. They have they range in, well, does the price include accessories, you know, the flooring, the painting, the range, the dishwasher, etc., or not, or you want to shop that yourself. So they have a range of prices. Lastly, you can fill in any other comments or questions you want, and I would appreciate your name and email address so Steve and I can get back to you. We're not going to share individual responses with anybody else. So in that regards, your names and emails will be kept confidential. So again, I'd appreciate that. So with that, I'm pretty much done. Unless there are other questions for either Ken, me, or Steve. So
if anybody wants to save the chat, go do it now. You can save it by finding the 3 dots in the chat window and clicking on that.
I could show the responses, but I know that the previous ones, a couple that I had, weren't terribly promising, but I just look at the first question is really the thing of interest. Okay, good. So I got a bunch of somewhat interested and a bunch of people with the not interested, but it's a passion of theirs. So maybe some of those people will be try to get together and see who can help drive this a little bit further so that we can move forward and have options available to us. Okay, with that, let me give it back to Steve or Pat. stop sharing.
Thank you, David. That was great. People can continue to fill out that survey and it'll get back to you even after our webinar is over with. The link is in the chat, I believe. And also in the chat are several posts that I made of further information on community solar and how you sign up with Arcadia. Gave you the link. So you can find out, first of all, if your community will have a nearby community solar, and then it'll offer to help you get signed up. And then you get put into a big queue for when the system is available. There are, I think most of them are completing this summer. Of 105 are completing by this summer. And I'm told that they may be sold out by this summer. So you'd better get yourself in the queue before this summer. That's my big advice to you. So we really appreciate Ken and David. Thank you very much. I will send out the recording and I'll send out the chat as well when I do that to all who registered, and the slides as well. Ken is going to supply slides.
Yeah, absolutely.
Thank you. Great. That's great. So thank you very much. The next webinar will be Thursday, February 16th at 7 p.m. And we have Yanette Viasis, who's the community engagement manager for Solar Landscape. They're building half of those 105. And so she's really an expert in what's happening in New Jersey. She'll be on the show in 1 month. And I have her contact information. I'm trading information with her just about every day, by the way. So if you have more questions, I can feed it into detailed stuff. I can feed it into her and get you the answer. That's all I have today. Thank you for joining us.
Great. Thank you so much. Have a good night, everybody.
Good night, everybody.